Cambridge Muslim College, training the next generation of Muslim thinkers.
All right, good afternoon, everyone. Hope you all had a wonderful lunch. My name is Abubakar, as Yaqub said. So both of us, we are machine learning practitioners. We're the kind of people that train neural networks for fun. And today we're going to be talking about one particular application that I think is very interesting, which is training machine learning methods to give you fatwas that are reasonable, that are reasonable and realistic. And we'll talk about how close we are to making something like that happen, and what kind of questions might be raised if we are actually able to do that. So I'll hand it off to Efe to get us started.
Our motivation is the Turing test, and it was already discussed previously during the conference. Alan Turing has developed this test to understand if, or to conceptualize and better reason about if machines have or can have intelligence or not, at least at a behavioral level. So he developed and proposed this imitation game where an interrogator is trying to distinguish between a machine and a human in a certain task that requires intelligence. So Turing's polite convention is that if a machine can act as intelligent as a human being, then it is as intelligent as a human being. Of course, this approach has some theoretical problems, and there has been raised a lot of criticism to that was also presented here. One of the big ones is the simulation of intelligence. An agent simulating intelligence can pass the test without actually essentially having intelligence itself. So it's a very functional, behavioral, and materialist approach to thinking about the intelligence to what Alan Turing was proposing. And the Chinese room argument was presented to better conceptualize it as an example where basically in a room there can be someone who does not know Chinese but can communicate with the outside world following some instructions about what output to give when someone proposes something inside the room in Chinese. And that way from outside it seems like actually the person inside understands Chinese, in fact when the person does not. And on the other hand, another theoretical criticism to the Turing test is an anthropomorphic one, which is that the ability to distinguish between the human and the machine is also limited by the ability of the interrogator. Basically, the person who is trying to distinguish if the machine or if the output or the intelligence is driven by the machine or the human. But as my colleague Abubakar was saying, besides all these theoretical criticisms to the Turing test, at a practical level, the Turing test actually has a very good application in terms of understanding how AI scientists who develop these algorithms think about this problem. Because besides all these these theoretical concerns, when AI researchers develop algorithms, they look at it from a very behavioral and performative perspective. They look at if an output of the algorithm can surpass the human intelligence or human performance or not. And they have the same approach that Alan Turing had. That's why we think the Turing test is very important in terms of understanding how people who develop these algorithms or methods are thinking about machine learning and artificial intelligence. So the question we ask is, can AI produce fatwas that can pass the Turing test? We think this problem is very important because fatwa is a tangible outcome of the Islamic legal reasoning process. So when an AI researcher develops an algorithm and wants to propose that the AI system has actual legal reasoning or Islamic legislative reasoning, they could propose that since the fatwa produced by my system is actually cannot be distinguished from a human or is actually a very good outcome, it means it actually is practically doing its job. And also it's important to pose this question of if it can create a fatwa or not, because this has a lot of practical implications. Later on, once such algorithms are developed, or if they can be developed, as we will discuss later on, people might actually adapt these algorithms. And because in this case, the Turing test interrogators will be people like ourselves who are not necessarily scholars, looking at fatwas and thinking, well, the outcome I get from a computer is very similar to an outcome I get by a trusted scholar. They might actually start replacing the scholar and its authority, or their authority, with the machine or with the AI systems. So there are a lot of practical concerns raising from the applications or the ability to develop these systems. And also we believe that the Turing test is more relevant than other performative tasks or tests in this case, because Turing test is actually concerned about the interrogator, meaning that not just if the fatwa is good based on, or like very robust in terms of scholarly standards, but based on how people perceive if the machine output or the human output is good. In this case, as I said, as someone who may not know the Islamic legislative process really well, I may just confuse both of them, and then that would lead me to practical outcomes. Given that we would be basically talking about, like we will give a very short introduction to Islamic legal reasoning, how it works, and how artificial intelligence and machine learning systems operate, and we will propose a general framework of how a AI researcher or scientist will think about generating legal opinion using artificial intelligence, and then move on to limitations and promise of machine learning or AI-driven fatwas and contentions and promises with it. So the purpose and process of Islamic lawmaking is basically that Islamic law provides guidance for the religious, ethical, and moral conduct of a Muslim so that he or she can draw closer to God. It's very practical. It varies from how we say greetings to each other as Muslims or to non-Muslims, as well as where we give our money and how we think about justice, like concepts, very abstract concepts like justice, to very practical day-to-day issues. And fatwas answer questions that arise from day-to-day social actions and socioeconomic life of Muslims, and they are singular opinions proposed by jurists. And the process of Islamic lawmaking has a procedure where there are sources of Islamic law, which are mainly Quran, the prophetic example, which is the Sunnah, the consensus of the scholars, as some suggest, and the analogical reasoning or qiyas. And also there is the methodologies for lawmaking, which are developed to draw legal conclusions from these sources of Islamic law. And they strive to incorporate customer habits of the social context of society, the societal benefits, and as well as the higher purpose of the law in that process. So the question we pose is, can we technically develop systems that would be able to emulate or simulate or imitate that process and be able to pass the Turing test? And before we go there, just to understand better like how that works in practice, we can look at the example of intoxicant consumption and how that was considered or dealt with by the Islamic legal process and the scholars. So there are 3 Quranic verses that have gradually explained how Muslims should think about consuming intoxicants or things that have alcohol in it, for example. And then the Hadith tradition clarifies that the prohibition of alcohol was gradual, and there is scholarly majority that this prohibition applies to all other intoxicants based on the analogical reasoning that goes beyond just the wine or khamr at the time. And as I was saying, we see that it's a very complex process. It's not just one-time decision in many cases, and the question if AI can develop, if there can be technically systems developed to emulate this process. So before understanding that, let's look at what artificial intelligence is and how artificial intelligence works. So artificial intelligence is basically the capability of a machine to imitate intelligent human behavior. And there were 2 streams of thought in AI. The first one, which is very outdated and not used much anymore, is rule-based AI, where the basically programmers or the developers use pre-programmed rules like if and then, if this happens, give this output of sorts, like in the Chinese imitation game, for making decisions. However, today, the reason why there is so much excitement or hype around machine learning or AI is because there is a new way of doing AI, artificial intelligence, which is called the machine learning methods, where systems are developed to learn patterns from data and associations from the data to derive outcomes. And the learning takes place over time, where there is a training phase, and the trained algorithm can be directly applied on the future data, which is called the test phase. And the popularity has skyrocketed in the last years because there were many problems that were thought that only humans could, and with human intelligence could actually deal with, but now the machine learning-based AI systems can actually perform much better than humans. And a case study here is the Google Translate system. As we see basically here, the neural machine learning system developed in 2014 can translate between languages, which is a very hard task where many humans may fail or make mistakes without actually having any rule-based understanding of the system. So it just looks at the data about given the first two words, for example, here in this case, in Chinese, and how these two words associate with each other, how to turn that word into, in this case, knowledge in English, without actually having a rule about or a reasoning about it. So it only thinks probabilistically or statistically about when these two words come together, what is the most likely word to translate it into English from Chinese, and based on that constructs a outcome. And how would that translate into machine learning systems that could generate legal opinions? This is a very general framework for, in general, like just developing machine learning algorithms. There's nothing specific we ourselves propose. This is how usually machine learning systems are developed. There's an input data, in which case it could be a large-scale fatwa data set, from which the system extracts features, and these features are encoded numerically as numbers, and based on these numbers, associations are made, and the machine learning algorithm learns patterns to say if in a given new fatwa situation, if the outcome should be, let's say, farz, mandub, mubah, etc. And here it's also important to understand that not just the outcome should be given, but also the reasoning behind it. For example, here in this case, maybe the feature 1 and feature 3 may be associated with the outcome. So meaning the outcome can be explained by that being farz in this case for a specific question, may be related to the issues around the feature, perhaps that represent something in the hadith or the Quran, etc. So given that framework of thinking about if machine learning systems, frameworks, technical frameworks can be used to produce fatwa, I would like to transition to my friend Abubakar to talk about the limitations of that approach from a technical standpoint and potentials to improve upon them to see where we stand today in terms of machine learning systems.
Yeah, thank you, Efe. So that's exactly right. So we've painted this optimistic, this clean picture here. You have this system that you can build, and it'll actually give you a ruling. It'll give you a fard or something else. But how far are we from actually making this happen? It turns out that there are basically 4 key challenges that we've identified for why this is not as easy as it may sound, or maybe it doesn't sound easy. But there's 4 key challenges. The first limitation is actually something that we call domain shift. The idea here is that oftentimes we talked about training and testing machine learning systems. We train machine learning systems in one domain, or in one context, or in one setting. And then we try to test that machine learning system in a different setting. And so what we have here is we have some examples of a machine learning system that has been trained to identify weddings, pictures of weddings. Now, if it has been trained mostly on images that have been taken in the West, in North Africa or in Europe, it has a hard time realizing that the picture on the right is a wedding in Africa. And so the way that the analog here for fatwas is that oftentimes we have the same issue, is new fatwas are asked about contexts or environments that differ from existing fatwas. I mean, that's a big reason why the fatwa is being asked in the first place, is because a historical precedent is hard to find. So in these situations, oftentimes we have to consider not just superficial statistical similarities, but scholars will look at deeper similarities. Things like effective causes. What is the rationale? What are the customary habits of that society? What is the societal benefit here? And oftentimes this is not going to be apparent just from thinking about the fatwa at a high level. And we have a quick example here. There was a scenario during the life of the Prophet Muhammad where he was asked by women what to do if they started menstruating during the Hajj pilgrimage. And what he replied was to basically for them to go home before completing the pilgrimage and to come back after their period was over. Now, this is what happened during the lifetime of the Prophet, but after the Muslims expanded geographically, it became very difficult for Muslim women to go home during the middle of the pilgrimage and come back. And so later scholars opined that they should actually just complete a ritual bath and then finish the rest of the pilgrimage. So the idea is that because of the context switching, the actual fatwa, the actual judgment was switched as well. And so basically we need to come up with ways that can prevent fatwas from being biased because they've been trained on historical data and actually get them to generalize more effectively in new situations. So we're actually developing new kinds of methods to actually do this. I'll just briefly mention 2 of them here. One is actually just building better data sets. If you have better fatwa data sets that are more inclusive, you're going to do a better job of generalizing. But of course, this is not foolproof. You're always going to have new kinds of data. And so what you can do is you can do techniques like meta-learning that help you generalize more effectively. And I won't get into the details too specifically about meta-learning because it turns out that we have actually better techniques even beyond this that relate to the second limitation that I'm going to talk about. The second limitation is causal reasoning. So this is super important. So machine learning systems, they learn associations and not causations. So correlations, not causations. And so what this means is that machine learning systems are really bad at understanding what will happen if I change a particular factor through an intervention. So if I ask, for example, what happens if this person starts smoking, it's very hard to tell from data alone. And that's because data about smokers may differ in many, many different ways from data about non-smokers. So it's very hard to figure out what is the effect of a very specific intervention. Similarly, it's difficult to ask counterfactual questions. What if I had done this instead of that? And I'll give an example of that in just a second. So this is super relevant in the case of fatwas, and this is just one example here. So during the lifetime of the Prophet, he was asked to actually impose price controls during a drought that had afflicted Medina. And he basically said that it wasn't a good idea. He ruled that it's not a good idea because it would be unfair to the commodity suppliers. However, just a generation after the Prophet, a similar situation happened, and the major jurists of that time actually ended up ruling in the opposite direction. And the reason was that they figured that imposing these price controls now would actually be fairer. So they actually had to think about the mechanism. What's the mechanism here? What effect will the price control have? And that's very, very difficult to get through associations from the data alone. We actually need to build what are known as causal graphs, which is what I'll show here. We actually have to build things called causal diagrams or causal graphs. And what these do is that they help us understand how different variables or different quantities that we've measured affect each other. And the idea is that we build these through real-world experiences, through our knowledge of the real world, and then we train or we answer queries based on the data and based on this graph that are based on top of this graph. And this is part of a new trend that's gaining a lot of hype in machine learning nowadays called causal inference, proposed by many people, including Judea Pearl. A third limitation. Okay, so this limitation is kind of interesting. It turns out that most machine learning methods nowadays have a very, very hard time learning discrete rules. And that's because of what Efe mentioned earlier, which is that neural networks represent everything with real numbers. And if you represent everything with real numbers, you tend to be everything tends to be very gradual and very gradient based. You change the numbers a little bit and the output changes a little bit. The machine learning methods have a hard time learning very discrete boundaries and discrete rules. And so, for example, so this causes lots of problems. One problem that, if you're following the field of machine learning that you might be familiar with, is this notion of adversarial perturbations. It turns out that you can take images or audio recordings that the machine learning method can classify correctly, and then just change a few pixels here and there by a minute amount that a human eye can't even perceive. And that completely fools the machine learning method because it's so sensitive to all of these little numbers. The reason we bring this up is because it's super important when developing, for example, Efe mentioned earlier about how there's an usul or a methodology, a very specific methodology, how scholars take kind of the sources of Islamic law and turn them into rulings. And these rulings are very discrete, they're very systematic, they're very strict rankings, and this is just very hard for a machine learning method to learn. But there are methods that are being proposed that actually combine machine learning, kind of the typical machine learning methods, with logic-based rules, particularly by Hu in Carnegie Mellon University in 2016. They proposed a method that's gaining a lot of popularity. So these methods are now able to learn discrete logical rules as well. The final problem that we'll talk about is one of social context. And people have alluded to this before in various talks. But a good example of this is natural language. So if we're trying to train machine learning methods to understand natural language, it's actually a really hard task. And that's because natural language, the meaning in language is very dependent oftentimes on who is talking to who, what the background is, what the setting is. And it's very hard for a machine learning method to, for example, pick up things like sarcasm, because it's very, very context dependent. Even more problematic, actually, are things like that involve physical experiences. So we have this sentence here: Jane hit Annie, and then she ran off. We know from living in the physical world that if the sentence reads "ran off," that she is probably pointing to Jane, because when you hit somebody, you tend to run off. But on the other hand, if the sentence was "she fell," then that same word would probably be referring to Annie. It's very, very hard for things that are only trained on natural language data sets to understand this kind of subtle differences. Similarly, we have the same problem when it comes to fatwas, or the same concern. Jurists must understand the physical and psychological constraints that a person faces. And that's why fatwas, as Efe mentioned earlier, are very specific to a context, or oftentimes to an individual. And we have this example here about the division of lands. During the time of the Caliph Umar, he changed the way that the booty was being distributed, or the land was being distributed in times of war, because he was concerned about the psychological effect that that would have on the soldiers that were fighting. So people who are issuing fatwas need to take this into account, and so would a machine learning method. So those are the limitations that we've identified. I'm going to hand it back to Efe to talk a little bit about concluding remarks and what implications these limitations have. Basically, long story short, and I can talk more about this if people have questions, but there are methods that are being developed that try to take experiential or empathic learning into account, trying to teach machine learning methods, and more specifically robots, about what it is like to live in the real world. And the kind of holy grail here would be, can we train a robot to laugh when it sees an image like this? Okay, now I'll hand it to Efe.
So in conclusion, we have looked at why Turing test is actually, besides and given the theoretical problems, that is actually very important in understanding the projection and the trajectory of AI and its implication to society, because that's how people who use AI practically think about it. That's how the people who develop these algorithms think about it, in terms of if it can benchmark with people, if we can benchmark humans with machines. And so we have developed a perspective about how we think about Islamic legal reasoning from a Turing test perspective, which we have conceptualized as a fatwa process, because fatwa is a concrete outcome. And then we have laid down how to pass this fatwa test, what kind of problems there would be, and we have identified 4 problems, which are the domain shift, causal reasoning, discrete rules, and social context that machine learning algorithms cannot capture. And we have identified ways and promises in the current research trajectory to overcome some of these major challenges. And given that, we believe that it's really important to have this conversation, to have this discussion part of our broader conversation on AI and its theoretical and practical implications, because in either case, if such algorithms can be developed in reality, if these challenges are actually overcome by AI scientists, that might have implications to how people perceive the Islamic legal tradition, how they see the authority or legitimacy of scholars, and how they use Islamic legislation in their day-to-day lives. And that's why we believe that these questions should be raised as we think about the technologies developed behind AI. Thank you very much.
Cambridge Muslim College, training the next generation of Muslim thinkers.